Okay, correlation and line of best fit. We talked a little bit about correlation yesterday in passing. Correlation is the relationship. It has the word relation inside of it, right? Correlation. So, that pen's dead. In a scatter plot, there's a correlation. And there are three options for correlation. Correlation, again, has the word relation in it. It is the relationship between the variables or the values. The correlation is the relationship between the variables or the values. And there are three types of correlation. There are different elements inside of each type, but there are three encompassing types. There's positive correlation, where both variables increase. A positive correlation would be something like how old your car is and how many miles you've driven your car. The older your car, as your car's age increases, the number of miles it's been driven increases. Both variables increase. It's a positive relationship. There's a negative correlation, which is where one increases and one decreases. The number of people who attend the movie. The more people who go see the movie, the fewer empty seats. One increases, one decreases. It's a negative relationship. And then there's none or no correlation. There is no relationship. The number of brothers you have and your shoe size. Doesn't affect each other. People who have lots of brothers do not have big feet. There's no relationship. These are our types of correlation. You should have a little piece of paper that shows pictures of these relationships. It's going to just perfectly fit. These are examples. This is perfectly positive. It just makes a straight line. That rarely is going to happen with your data. This is a positive correlation because it both increase. As they increase, this increases. This is a little more scattered. It's not as perfect, but there is a correlation. There's a no correlation in the middle. Then there's a low negative. Even though it's not a very strong negative, you can tell that the data tends to decrease. a high negative, perfect negative. So this is our visual of correlations. Questions about correlations? Pretty self-explanatory, right? Positive increases, negative decreases, and then there could be just no correlation. Now we're going to talk about this idea of line of best fit. Line of best fit. Sometimes it's also called a trend line. And lines of best fit are predictive. And here's the kind of nuts things about lines of best fit. Your line of best fit could be different than someone else's. And that's okay, because it's an estimate. However, there are lines of best fits that are wrong. Even though it's an estimate, you have to make a good estimate. So there's some guidelines for lines of best fit, or a trend line. The first thing we ask is that when you draw a line in your graph, you want to try to have as many points above the line as below the line. Do not just draw your line of best fit smack dab in the middle. Or no. Like, if I was going to draw a line of best fit here, I wouldn't go like this. I want it to be in the middle of my data. I want to try to have as many above the line as below the line. Am I saying that you have to physically count it? You can eyeball it. But you want to try to have as much data above it as below it. So here's how we do it. Step number 1. Find the slope between 2 points on the sketched line. So when you're drawing your line of best fit, you want to try to have your line go through 2 points. How do you find the slope between 2 points? What's the formula for slope between 2 points, Donovan?
X2 minus X1 over Y2 minus whatever.
Perfect, but flip it. Rise over run, which is Y2 minus Y1 over X2 minus X1. After you find the slope, and I'm going to kind of squeeze my words right here because I want to glue this graph on the side that you have. You're going to use the slope in point slope form to find the equation. You're going to use the slope in point slope form to find the equation. Anybody remember point slope form? Here's a hint. You got to have a point and a slope. I'll start you off. Are you ready? Y minus Y1 equals m, uh-oh, I wrote too big, x minus x1. I've got a point and a slope. So let's look. I'm going to zoom in really close. Here's my scatter plot, and here's my trend line that I estimated, right? And if you look on that trend line, I've got an ordered pair here and an ordered pair here. So I can find the slope. I would do y, which is what, probably approximately 510, minus y, 305, over x, 22, minus x, 16.5. Again, we're estimating, right? So I can find my slope, and then I can put my slope that I just found in here, and my ordered pair, my x comma y in here, distribute and solve for y, and I have an equation. Glue this graph and then we'll go to the second page, which is about some more trend line information. You guys give your extra one to them. No, wait, I lied. All right, so carefully, someone at your table, you have a sheet of 3 graphs. You only need one, so share it with the people that you sit with. You need one of these, each of these graphs. One of each graph. So we're going to continue. Once you have this line of best fit drawn, you can use it as a predictive value. And there are 2 types of predictions you can make once you have a line of best fit. The first type of prediction you can make is something called interpolation. 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 That's the first type that you can make, is interpolation. What does the prefix inter mean? What does the prefix INTER? What if I told you that the first one was interpolation and the other was
Extrapolation?
So what do you think interpolation means? Into, crossing, inside. Interpolation is when you estimate a value inside the data. It means it's on the line of best fit. So if you look, this guy is an interpolation estimate. Because here's my data, right? This is my range of my data. This is my maximum. This is my minimum. And I can estimate that when it's 21 degrees outside, a store could predict to make around $480. That's interpolation. I have my scatter plot. I collected all this data, and somehow I didn't collect any data when it was 21 degrees outside. My bad. But because I see that this has a positive correlation, I can use the other pieces of data to help me make a prediction. This is interpolation. Inter meaning inside the data that I've collected. It fits between the minimum and the maximum. So I guess let's leave a little line and I'll put that in there. It's between the minimum and the maximum. It's between the minimum and the maximum. Interpolation is between the minimum and the maximum. Extrapolation, E-X-T-R-A, it's extra. Polation. If inter is between the data, what is extra? Outside the data, or outside the minimum and the maximum. It's when, I guess I can do this. You estimate a value outside the data. It's still on the line of best fit. But this time, instead of it being between the minimum and the maximum, it's outside the minimum and maximum. Bless you. Extrapolation is when it's outside the minimum and the maximum. And here's the deal. Both of these are guesses, correct? I mean, like, they're both estimates. They're not exact. When you extrapolate data, you have to just be careful that your line of best fit is correct. Because this has no data that's telling us, oh, well, you know what, it actually is close to this one, so I could use that to, right? It could be just kind of a guess. Now, it's an educated guess, it's a good guess, but it's still, both of these are guesses. So glue this on that part.